Hello guys, what's up? Welcome to my channel. This is the second day of the Ash Code with blog with Bob. And yesterday I released a video on how to set up Solidity files, how about the structure of Solidity of smart contracts and introductory knowledge about the syntax and how to define data types in Solidity. But today we are going to go properly into understanding utility data types, how we can work with them, and how we can define our own custom data types in Solidity. So without further ado, let's get started. So I'm just going to be sharing my screen right now. Um, Sharing my screen, everything. Okay. Sorry, I'm just trying to share my screen. Okay. Okay. I'm sharing my screen right now. That okay. Playground. Okay. All right. So right now, today I'm going to be using chain ID. Yesterday I used a Visual Studio Code, but I get to understand that it's much more better using the online ID like Chain ID. I've worked with it several times and it's really cool. And it enables you as a developer, even as a beginner, to really code very fast and helps you to solve a lot of mysteries. And right now, um, you can see I'm on the Chinadi page and I'm trying to connect with my GitHub. So please, I don't think I get paid for this. I'm just a fan of Chinadi and I really love what they do. So I think it's one of my ways of contributing to their growth. So right now I'm trying to connect to Chinadi with my GitHub account. So let's wait while that pops up. Okay. All right. Right now I am there. So I think there are a lot of changes since last I visited. Say already processing X request. Okay. What is telling me here is I think let me just okay. Um okay. It's telling me that MetaMask is still processing and I've not connected my MetaMask. So my MetaMask is here. So let me just unlock MetaMask. Okay. All right. MetaMask is connected. But let me just refresh this page. Okay. All right. So right now, let's get started. Also, I'll be minimizing this. Okay. So I'm on the chain ID page. We are going to be using chain ID, that is chain in the integrated development environment. It allows you to code in Solidity. If I were to be developer, it really helps you save you time and fast and efficient. So here we have different templates, but right now we're not going to templates. We just need to do something very very short. So let's come here. Okay, so I'll be using this storage the soul. I'll be using this storage the soul, and I can rename it. I think I can rename it. Yes, just rename it to solidity data types. Solidity data types. Okay. All right. So we are there. So I just change the contract name. Solidity data types. Okay. All right. So right now we are everything inside here. I'm just going to remove all of them. So we have a bare empty contract that does nothing. Okay. All right. So what is solidity data types? I'm sure we all understand. Last time I explained to you what solidity data types is. And like I told you, solidity is statically typed. So the data types for each variables must be specified even at compile time. The variables can only accept data types for which they were designed, by the developer, and cannot be altered dynamically. Okay, so one thing about good thing about solidity data types is that we have the elementary types. Okay, the elementary types, and you can actually create a custom types from the elementary types. For example, unsigned integer 256, I call it counter. This is an elementary type, and it's global in solidity because we can actually access it. So what we did here is we define a data, we define we create a variable called counter, and we declare the type of data we are using that is going to hold as an unsigned integer 256, and that's the max. So here I can actually restrict this counter to unsigned integer 8. Okay, I can receive this counter to unsigned integer 8. So when I do something like this, it means that this counter cannot hold any value above the range of 2 raised to power 8. 2 raised to power 8. 2 raised to power 8. Okay, that gives us about that's 256. That's 256. Yeah. So what it means is that this variable counter cannot exceed this. And when it gets to this point, it rounds back to 0. Okay, that is what we call on the overflow, I'll be underflow, sorry. So it's always good to be safe and to understand all of this data, all of these types before why you are using them, so that you don't run into some errors. Okay, all right. So let's look at some other data types. Let me just do something here. We also have unsigned integer 16, for instance. Let me call it counter 2. Counter 2. Okay, I'm just going to, okay, yeah, okay, all right, I think it's better this way. So I create another variable called unsigned integer counter 2, sorry, which is of type unsigned integer 16. So here I can specify it as public. I can say it is public. I can specify this one to be private. Okay, all right. This one means that other contract cannot access it, but on the blockchain, it doesn't mean that this one cannot be seen. Data are public on the blockchain. Okay, most of the blockchains, Ethereum's and other layers of other layers like Polygon. So data are public, But this one, when I define it as private, it means that other contracts, cannot access this variable in my contract. So why I'm creating here, let me explain something to you. I say unit 8 private counter, I set it to um let's say 400, for instance. When I set this to 400, okay, this is wrong. This is an error. Why is it an error? You see, at compile time, you can see that I am not getting an error for it now, because this is what we call a logic error. Okay, I'm not getting an error for it because it is not running, and because Solidity sees that this is actually correct. So because until when it is running at runtime, that is when this error will come outside. Okay, so if I say I set it to 400 now, okay, let me show you example. Let me show you example. Create a function. Create a function called increment, increment, sorry, increment. Okay, all right. So I say it is public. Then what the function done is that it simply increments the counter plus plus. Okay, all right. So what am I getting here? Okay, all right. So I think yes, I was thinking it was not going to show us error before, but you can see now that it's showing me the error that literal is too large. Sorry, convert okay, type int constant 400 is not implicitly convertible to expected type unit 8. Literal is too large to fit in unit 2, unit 8. Okay, what is saying here is this, that I define this type of data to be unsigned integer 8, which is 2 bits raised to power 8. Okay, 2 bits raised to power 8. And what this means is that this variable counter can only hold up to 2 raised to 2 times 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 2. Okay, let's count it. 1 2 3 4 5 6 7 8. Okay, and this is 8. This is what it means, that 2 in 8 places. Okay, 2 in 8 places raised to power 2 power 8 will give us the total number. If you calculate the calculation, will give us 256. Yeah. So now, I think Shinadi is very good, because this kind of error, I probably will not get it if I'm using the Visual Studio Code. That's one of the benefits of this IDE. So it's really handy. So right now, this is very wrong. This is not correct. Okay. So if you are defining data, you're using integer 8, and in the future, you are expecting that this counter will grow and it will grow up to 400. Then it is not okay to use unsigned integer 8. But now if I say okay, I will use it as 2 252. Yeah, so I probably will not get error. Okay, can you see I will not get error because this is not up to 256. So let's compile it, and I'll try to increment this counter up to 256, and you see the error that you will get. So let us compile it now. So I'm compiling it now. On the right side here, you see the button to compile. So now, when I expand this, you can see that our contract is compiled already. So let's try to deploy and run it. Deploy transaction here. Okay, so compile contract, compile successfully. 4.8.17. Let me compile again. Okay, successfully compiled. So I should be able to deploy. Hmm, I'm not seeing. I think it's something I'm missing. Sorry. I think there's an issue here. Maybe it's network. I don't know. But I think this compiled successfully here. So I expect that it should. I expect that it should pop up here. Hmm. I expect that it should pop up there. So I really don't know what the issue is. But hmm, okay, I'm not importing. Why is this not okay here? So let me try to refresh. Let's go. Let me try to refresh. Okay. All right. So I think yeah, we got the issue is solved now. It pops up. Okay, this is what I was expecting. You can see, you can see. So I cannot deploy the contract now. Let me deploy. So it's asking me for to confirm this transaction. Sufficient gas. Okay, I think I'm in the wrong. Just going to reject it. I think I'm using the wrong network. Let me try to switch my network. Okay. Um, Polygon. I think I have Polygon here. Yes, I have Polygon here. Yeah. Okay. All right, great. So let me try to deploy again. Okay. All right. So what is it saying? No wallet connected. Please select one at least. Okay, wallet connected. Connect wallet. Okay. Get a Web3. Poly no, 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 no. I'm not connecting to Polygon mainnet. I'm not connecting to Polygon mainnet right now. No, 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 no. Cancel this for me. And buy. Yeah. Mumbai is added successfully. It's connected. Okay. All right, great. So right now, let me deploy. Okay, I'm deploying. You can see now, unknown processing time. No, that one does not matter. Okay, let's wait while the transaction confirm. So you can see from here, transaction is waiting confirmation right now. So and it deployed successfully. Okay, so we have it deployed successfully, and you can interact from this tab. You can see we can interact with our smart contract here. Okay, all right. So now let's see what happens. You can see here I created a data assigned to your 8, which I set to 252. It was hard coded. Since I had coded 252 here. So and then I try to increment from this function increment. It will increment this counter. Okay, I want to increment it up to this point. So let me try to increment it now. I think I will have to be using injected JavaScript, not okay. Waiting for confirmation. Okay, that's done. So if I come here, okay, I actually set this to private. That is why it's not showing up here. But let me try. Now this transaction is successful. Now you can see it's successful here. It shows green. So let me try and increment again. So now the first increment sets this to 253. So the second one, let's see what happened. So I think I have enough mathematics to do that transaction because the fee is quite cheap. So I can actually afford to run even up to 100 times. So now we have second increment set to 254. So let's run it again. Let's run it again. Okay, this is the third time we are running. So third time 254 should set to 256, 253, 255, sorry, 255. Okay, all right. So another increment. This is the fourth time. Okay, so now we got an error. Okay, all right, you can see 255. It's three times, it increments it to 255. So they probably basically if this data give us the conversion give us 256. So the highest it can go is 255 because in the EVN it's always represented as 2 in 2, sorry, type of assigned integer 8 dot max minus 1. Okay, this is how it's always represented. So that means so the type of this data, which is unsigned integer 8, and dot max, the maximum is 256. Okay, so that means 256 minus 1. So that means, sorry, 256 minus 1. So that means the highest we can go is 255. Is 255 to avoid uh underflow or overflow. Okay, this is 255. So now we get a warning here that there's an error. So our application is stuck here. You can see, let's just try and submit it. You can see gas estimation error with the following message. So when you see something like this, that means there's an error in the contract. So the contract will probably fail. Okay, let's continue. So we have seen how to work with data. So instead of us to use unsigned integer 8 to represent this 256, we could just increase the memory space to what? To 16. Okay, so we know that in the future, if you implement this, okay, so if you do the calculation for unsigned for unit 8, so if you say that is 2 raised to power 16, that will give us about 60,000 plus or something. Okay, all right, so that is how to work with unsigned integer here. So let's look at the other data type. So another data type is boolean. Is bool. Okay, bool. So what bool is always represented as true or false. Bool, true or true or false. Okay, so let me just say is incrementable. can increment, okay. So now by default this can increment the false to false, default to false. So by default, it's always if you specify, if you set this unsigned integer, let's say we set it to 256 or 216 rather. So default value is 0. If you do not set it to 256, default value is 0, and for bool, default value is false. So right now, let's say we want to increment this counter. Okay, want to increment this counter only if this can increment is true. Okay, then we just have to say require that can increment is true. Then we just specify the error value. Okay, all right, this is valid right now. So what it means is, can you see this one? I will come to that later, but right now it's just a kind of a check. We have seen how bool works, a boolean value. Okay, the bool data type is used in Solidity, to illustrate cases that have a binary result, which is a 0 and 1. So that is what it's represented, and it always has to fixed value, which is either true or false. Okay, all right. So next one is bytes. Bytes. By Let's call it some data. Some data. Okay, some data. So how byte works is this. Byte is a kind of data that's and that it's an encoded data. It's also hold it can also use to hold string values and in Solidity. Okay, but it's much cheaper when you use bytes than when you are using the string. Okay, so we may not explain everything to you in this video because the video has to be short. Then I will just drop a link for you where you can read more on these data types. So this video is supposed to be how you can use and manipulate this data, so byte some data. Okay, then we can also say string my name. Okay, all right, string my name. This string now is holding a value. I'm not saying I'm declaring a variable called my name, and the type of data it will hold must be a string. So here, if I come here, I create a function. And I call it set data, and I'll say it will take in string I set it to memory. Okay, because I'm creating a copy of that. And I say give me your name. So it's public, that means anybody can access it. And now I cannot say I want to set this data my name. Okay, my name, and now set it. Instead of setting it to this my name, now I'm taking this from user. Okay, so and look at it, I'm expecting this type of data to be passed to me, which is string here. So now let me change this. Let me remove this. Sorry, let me remove this and set it to bytes name. So let me now set my name is equal to name. Okay, so yeah, probably might not get error. Okay, so let's see what happens. Okay, there's an error here. Data location must be memory. Okay, bytes memory. Okay, data location must be memory. Why is this memory? Is because we are taking in this is just an input from the user. This is an input. So when you are taking an input from the user, the data location, the data resides in the memory. We are creating a copy of it in the memory. So this name, okay, it's we're trying to set it to this name. So they are two different. This one exists in the storage, in the state storage, and this one exists in the memory. So but any change to this one does not affect this. Okay, any change to this one does not affect this. I will still give you an instance of that later. So now what we are getting an error here. This was an error. It said type byte memory is not implicitly convertible to expected type string storage. So what it's saying to us is that hey, look here, you told me here you were going to give me a string, okay, and here you are giving me a byte, because the type of this data is a byte, and you are giving me a byte, so I'm not going to accept that. So unless you give me what you told me earlier that you give. So right now, for us to make Solidity happy, we have to change this to what? To string. I'll change it to string. Yes, Solidity will be happy. Okay. All right. So let's see what happens. The error is gone already. Can you see? All right. So that is how to work with string data type. Then again, I could say this byte here, I want to set this byte some data. Let me now say function create some data. Okay, I'm expecting bytes. So let me just say bytes memory um underscore data. Okay, and I set the visibility to public. Anybody can call it. So right now, and I'm not saying I want to update this some data here. I want to update this some data here with the value of the data that the user is passing for me. And I'll say some data is equals to underscore data. So what I'm doing here is I'm doing an assignment. Okay, so don't do me that mistake. This, what I did there is declaration. I declare it. I declare a variable in the mail that, okay, this variable is just a reference. Okay, in this contract is a reference to a value, and that value is not set because I have not used the assignment operator here, so it's not set. So here I'm using the assignment operator, so I set it to this value. So now my data, this some data will be having this value. So right now you can see that we did not get any error because this is fine, because we are expecting bytes and we give it bytes. Okay, so right now let me change this to string. Let me change this to string. So let's see what the IDE will tell us now. So now you can see we got an error. That's Gennady is very good. I really love this. They have really improved. Here you can see that we have type string memory is not implicitly convertible to expected type byte storage. The same error we got the other one when we did. So can you see it has highlighted it for us, pointing in that this value you are giving me, it's not good. So I don't want it. So right now, but there's something we can do here. Okay, let's say the user, because string and bytes, they are convertible to the explicit conversion. You can do explicit conversion between string and byte. Explicit conversion, because string is an array of character. Let's say for instance I'd coded this. I say my name is equals to Bob. Okay, all right. So what this means is string is an array of character. So string takes a lot of memory. That is why it's not always advisable. Okay, so if you are writing your writing smart contract, sometimes you might run into error when you use too much of string error messages. Sorry. So when you use too much of it, you might get error because it will occupy a lot of space, and the size of the contract will be too huge, and it will go above the expected size, that the EVM or the blockchain you are deploying onto is accepting. So right now, this quote and this quote here, and we have three characters inside this. So it's an array of character. So this Bob B is a character, O is a character, so also the other small letter B. So right now, and each of these B inside occupies a space in the memory. Okay, so and you can this data, this bytes, this some bytes now, okay, occupy just one slot in the memory, in the storage, while this Bob occupies three different slots. in the memory, three different slots in the memory. In fact, it's four because there's when you I think I'm not going to go to that because of our time here. I will explain that in the next lesson. Okay, but basically you just need to know that this bulb occupies more storage than this byte. But now we can convert. So you say we can convert this string, convert it to bytes here. So how do we do this so that Solidity will allow us to go? So far our user is passing in a string of data. Let's say we are expecting him to give us link. Let's say, for example, we say, user, please give us the link to your profile. Okay, and we want to store it in our system as byte. That means we want to encode it. Encoding, that process of converting this to this is called encoding. So we are going to say, now I'm going to just use what is called bytes. Okay, I'm going to construct it. Construction means I am wrapping it. I am wrapping this byte around the string. Then for you to do that, you have to call it, because it's a global function in Solidity that you have to invoke it by using this brace. In programming, generally in programming, when you specify this brace means you are invoking a function, you are calling a function anytime you invoke it. So it works pretty much like a constructor. Okay, you are constructing this is the construction time, you are constructing it. So let me put now link in between. Okay, so now let's see what it tells us. Can you see now the error is gone now? So you can see that we did not get any error again. That is one of the ways to manipulate data in Solidity. Can you see now that I am expecting bytes here, and I say, okay, give me, as a user, give me some bytes. But I know that the user don't really have this time, and they don't have that expertise to be converting this link to bytes for me to store in my storage, so that I can be able to reduce memory or storage or the space I'm using. But I have to do this for them. So so long you are passing this string for me, this string as specified here will ensure that the user is passing in this type of data from a string. So this one is doing this checking here. Yeah. So, and I am also doing the conversion here by converting this link to bytes and store it in my in the storage here. So that is one of the way we can actually manipulate data. So let me show you another way we can also manipulate data here. Let me say, for instance, here I specify, okay, that counter should be unsigned integer of 256. Okay, and here, no, sorry, 16. Okay, 16. So, and here I say function, I create a function. I now say, okay, um let me use the word set counter, set counter. So I now specify unsigned integer here. And by default, when you don't affix anything in the front of this uint here, it defaults to unsigned integer 256. Can you see this one is explicit? It's explicit. That means I set it to unsigned integer 16. I define it. So, but this one, I only define the default, which is, sorry, I only set it to unsigned integer without preparing in using the number or the type of number it will hold. So this one will default to 256. So right now, I now say underscore counter. Okay, give me the counter, and it is public. Okay, so what I'm going to do for me is this: just set this counter. Okay, let me say, for instance, let's assume this is constructor. Let's assume this is constructor. Okay, or this one is wrong. Remove the function. Okay, all right. And I'll remove the public here, because in the later version of Solidity, you don't have to use this public as visibility, because the new version says you don't have to use that anymore. But from Solidity between 0.5 downward, I think, yeah, 0.6 downward, you have to specify the public as visibility. So now, okay, I want to set counter here. I want to set counter here. This counter in the storage. I want to set it to counter in the memory. I want to copy it to the storage. Okay. All right. So here we'll get an error. So let's wait for the error to pop up. So right now you can see now we get an error. It says that type U256 is not explicitly convertible to expected type U16. So what that error means is this, that here I said I defined unsigned integer 16. I created a variable called counter in my storage, which is a reference to what, to a value in my storage. And at this point, it's not holding any value and it is private. Okay. I'm just setting it to public. Let me set it to public. Anybody can read it. So right now, this is holding a less value. Remember, I told you that 2 raised to power 8 is 256. So if we do a calculation, let me do something here. Calculator. Let me do something here. Calculator. Okay, let's wait. All right. So let's see what unsigned integer 216. Let's see what it gives us. Let's see what it gives us. So we say 2 raised to power 16. What does that give us? So can you see? So this is the maximum value. This is the maximum value. So the maximum value that this unsigned integer 16 can hold is this. Is this. Okay, all right. So actually it should be -1. Okay, it should be -1. Remember I told you about that. So we'll remove the comma. It should be -1. So you can see that this is the highest number that this unsigned integer 16 can hold is this 6555 65536 -1. Okay, what is this saying here? Is there any error there? Okay, so that's highest you can hold. But now we now say here we are taking this counter from the constructor, which is of type in 256, unsigned integer 256. Okay, so right now if you check from the calculator, let's check from the calculator. Let's say 2 raised to power 256. You can see the huge number, very huge number that it gives us. So this huge number is obviously far way bigger than this guy. So Solidity is warning us that that is very wrong. So right now, one thing we can do here is this. When we know that even though this user here is passing in a number that is even lesser than this, Solidity is not going to accept this at compile time. Okay, because it's trying to foresee that error ahead of time. What is the error here? It's not showing up. Then error here. Okay, just gonna say 30. Okay, all right. So what I'm going to do here is this. For us to be able to say, okay, user, I am when you're passing in this for me, maybe we trust the user. Let's say for instance, yes, sir, I trust the user that is sending this data, that okay, that is giving me this input, that the input is giving me is going to be what I'm expecting. So now I am trusting the data, so the user, sorry. So right now, and I'm going to say, okay, so while I'm trusting the user, let me just satisfy Solidity by wrapping this, okay, by wrapping this inside unsigned integer 16. Okay, so I'm just going to say you in 16. I'm just going to wrap it around. I call it, I pass in this stuff here. So you can see that the error will go away now. So the error is gone now. So now Solidity is happy. So what we tell Solidity now is this: we try to manipulate Solidity that okay, look here. I already told you that I'm accepting this data, this is data type, but now the what this user will give me will not be up to what you are thinking it will pass. So right now, and you will not allow this user to pass in this data for me. But now Solidity, just chill. Okay, use UE16. Whatever is coming, it does not matter. Put it inside there, and so long it fills inside this data, accept it. So that is the way we make Solidity accept this data from the user. Okay, but this logically at runtime, when we deploy these contracts on the blockchain, we could get error and we could run into troubles, especially where we are using this to calculate some monetary value. Then we could really run into big problem, because if the user accidentally, or maybe the user decide to misbehave, the user decide to change his mind and say, okay, I'm passing in more than what I told you I'm going to pass in, then our application will get stuck here. Because this value, let's say the user now passing in a huge value like this, now passing in this kind of value, let's say the user now had more is zero. So we'll be getting problem. We'll be running into problem here. Okay. Creating now say, okay, lie, I won't accept this from you. Can you see now? So we got another error. So that is one of the ways to manipulate data in Solidity. So right now, let's look at the address type. Address owner. Okay. All right. Public. Let's set it to public owner. Sorry guys, my keyboard is actually misbehaving, so please bear with me. So now another data type in Solidity is called address. Okay, all right. So an address value is specifically designed to hold up to 20 bytes. Yes, 20 bytes. And what it means with 20 bytes is this. Oh, let's say, and it's always prepared with an X value. Okay, it's represented in X value, but it's holding 20 bytes presented in X value. This is how it works. So I now say, okay, owner address type OX. This is in X, okay, hexadecimal. That is what it means, hexadecimal value. Then it has to hold 20 bytes. That 20 bytes means that, let's say, some gibberish text, um some gibberish text. Okay, let me just, instead of doing that, let me just copy some address here. Just copying an address from my MetaMask. Okay, let me just copy this. Okay, all right. So you can see from here. So now let's examine what it means that an address is a type of data that is holding 20 bytes. Okay, let's figure it's let's calculate from here. 1 2 3 4 5 6 7 8 9 10. So 20 bytes, sorry, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, so you can see that I will broke this thing down to 20 bytes. Each of these, which is in two, is a byte. Okay, because there are two, each of these is a bit, so two of them is a byte. Two of them is a byte. Okay, all right. So, and you can see an address format, on an Ethereum address format is always, if you count each of them, it's always like 40 characters. So plus this one would be 42. Okay, but basically it is 20 bytes. Okay, all right. So let me just okay, all right. So that is what it means. The address. That is how we represented address type in Solidity. So this how can we use this address in Solidity? This address type, we use it to represent to identify um uh, anyone interacting with our contract. Okay, all right, we used to identify them because every message sender, why we creating a contract here is because we want to be sending and receiving messages. Okay, we want to be interacting with it and interacting with outside world. I want the outside world to interact with it. So, and for anyone that is interacting with our contract, there has to be a way we can recognize them. Okay, a way that constantly we can, though the value can change. Okay, because if user A is coming, user A will be having a different identifier from user B, and also user C, and so on and so forth. So now we now say we are going to be using this address format, which is generated from kind of a value, but not, this tutorial is not covering that for now. So now we can say our owner, we generate this address and we represented this as the owner. So when next the owner, anyone is interacting with our contract, we can decide to say, okay, this is the only person, this is the person who owns this contract. This is the deployer. So also this is the owner. Okay, so I have this address set in MetaMask, which I copied from here. So and 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 this address belongs to me, and I can be the one to control this contract. So that is what it means. So next time anybody is calling, we can run a check that look here, check if this person that is calling, if it is not this owner, then please don't accept. So that is what it is. And there are two types of address on Ethereum, basically. And we have the smart contract address, and we have an externally owned address. So this address I placed here is externally owned address. We call it EOA, externally owned address. That is what it stands for. Okay, so these externally owned accounts as they have how can I put it, private key and public key value pair or something like that. There are way you can get the public key from the private key. You can convert it both and fro. Okay, all right. So but in contract address, it's not that way, because contract address, we generate it after we deploy it on the Ethereum. Though there are other ways we can compute the address ahead of time before deployment, but later on we get to understand, because this is actually like a beginner course. So you don't need to have I don't need to bore you with too much complex stuff. I'm just trying to simplify it as much as possible. So that is all about address right now. So excuse me. So the next data we are going to look at is enum. Enum. Enum, let me say enum, I'll move it up here. Enum stages of life, stages of life. Most things, most objects, okay, as in uh um any calibrate, anything you see defined like this and precede, and you see calibrates in front of it, they are basically objects. Okay, this contract here, the only thing what makes this one, because this contract is the top object reference, while all this one are members of this top object reference, which is the contract name. So everything inside we define here, they reside inside this contract Solidity data types. So we can always access any of this data using these Solidity data types with the dot notation. Okay, so you can always say in another contract, you can say solidity data types dot. You understand? When you say dot, then all of these, any of these attributes, all of these properties, properties of this contract are, they are readily available. Anyone that is specified as public, but anyone that is private, other contracts cannot be able to see them. Okay, so this one is an object. Enum is an object. Okay, but how enum works in Solidity is that it consists of user defined data types. Okay, and these data types is used explicitly for constant values. It's used for constant values. Excuse me, such as the name of an integral constant, making a smart contract easier to read and maintain, and so on and so forth. So, what does it mean? Excuse me. What does it mean for this the content here, the element here, to be constant? Okay. Look at these stages of life. The stages of life we have: childhood, and anything you are defining inside enum must be capital letter, all through uppercase. Childhood, then we can say um childhood, adulthood, adulthood. Okay, there are two stages of life: childhood and adulthood. So what it means that each of these is represented as an integer. Okay, integral. These are integrals to one another. This flows from here to one to the other one. Okay, so we can always convert it back to the other one, but it always defaults. This one defaults to zero. These stages of life now. Okay, we define this data. This is constant because anytime, any day, this childhood here will always be represented as zero, while the next one as one. So it works more like a list, like an array. Okay, an array are always zero base, so that means a zero indexed. You start with it counting from zero. So this one also work almost the same way, but in a different way. So let's assume that we are now declaring, because this is constant, it actually does nothing now. We just define it constantly. It's there, it's holding the same value. Let's now say stages of life. Stages of life, want to define it in our state. Stages of life. You know why this one is constant, is this: you can actually define this enum. You may not really define it inside your contract here. You can even put it in your interface, in your library or so. Okay, but you cannot put your date, your storage in the interface. That is why they are different. So this storage will always reside in the contract, or hold or head somewhere in library or so, but it will only be executed in the context of the calling contract. Okay, so stages of life, let's say it is public, and we'll call it stages. Okay, so right now what we do here, we did here is declaration. Okay, declaration. So by default, and anything, any data types in any programming language, generally they always have a default value, and this enum is a user defined type. It's a user defined type because we define it. It's not Solidity that define it for us, but we use the elementary type, which is the enum key value, sorry, enum keyword. There's an enum is an elementary type in Solidity. All this one, they are elementary type, but here we now change it that okay, Solidity is not allowing all this data. We need to do more than what Solidity has given us. So as we say, I allow you to create your own custom data. So that when I'm not creating my own custom data, that okay, this is stages of life, and it will have a childhood and it will have an adulthood. So it is okay, that's fine. I accept this from you. So right now, I now define this in my storage. I now say stages of life, we have a default stage, and with default stage is a childhood, because when you are born, you are always going from the childhood to the adulthood. Okay, you cannot start from the adulthood, and I've not seen that kind of life before. So stages of value, stages of life, stages. But then we can decide to set this. We can decide to set this. So, but basically, what this data is holding now, these stages, we are defining it with this reference here, which is the name, and it's supposed to be holding to be referencing all of this data in the story, in the some of this data constantly, but it's not going to work that way. And why we say it is this an integral constant is because this stage will be representing each of data, each of the element inside this curly brace, each what just one and not everything. It's not referencing everything, it's referencing just one. So whenever we call this stage will always return this childhood to us as being the default value. Okay, so but we can decide to change it, that okay, let this stage, our first stage is starting from, maybe we want to be different and we want to be creative. Okay, our stage is starting from what stages, because we don't forget we have to always use that data type we start with. Whenever we define a user defined type, is you start something like this, we always have to referencing it by calling that name. Stages of life dot, okay, dot adulthood, okay. So that means we are setting the default value to adulthood, and you can decide not to use that dot, because this is a curly brace, this is a curly brace, so it is an object, it is seen as an object, and inside that object there are what integer, there are elements, sorry, yes, element inside of it. So we are assessing the member, each of these member, using the dot operator. Okay, that is why we can use that dot operator, because this is seen as an object. But then if we don't want to use it, we can also call it, because objects in most programming languages are also a function, especially in JavaScript. They are also a function. So we can actually call this like the function to wrap up or to do a kind of a construction. Okay, maybe we are setting a value, or we are setting it for the first time, or we are changing things. Okay, so we can also say, instead of doing dot notation, we can just call this object as a function. Okay, we are invoking it, and while invoking it, it must take some parameter. That parameter, it has to reference everything, any of the element that is inside the curly brace. So let's say this one is a list, so is standing in the first position, and this one is standing in the second position, and inside an array, and the rule of an array is always a zero index. Okay, you start starting from a zero. So this one, if I want to reference this now, I'll just pass in a zero. Sorry, I'll just pass in a zero. So I am defaulting this value to childhood. So whenever I call this, as I call this now, I'm invoking this. I'm invoking this now. So it will always give me this value. So if I want to reference this value also, I'm just going to pass in 1. That is it. So, but if I pass in 2, that is an error. It will give me an error, because I have not defined any element in that position. Anything in that position is 0, 1. So there is no 2. So I'll get error here. So look at what it's telling me. Explicit type conversion not allowed from integer constant 2 to enum solidity types dot stage of life. So it's just an English. So what it's telling me is that I have exceeded that an out of bound error. I have exceeded the limit I specified in that object. So that is it. So let me just return this one. I'll just remove this now. All right, so that's it all about enum right now. So because of our time, let's quickly look at one more, call mapping. Okay, you can see now I really love chain IDE, because this is interesting. Things have really changed since last time I used this IDE. Okay, I love it so much. So mapping type 1, type 2, name. So what it's telling us is that a mapping is a what is a storage location. Okay, it's a storage in our contract, and that storage, like we want to create in programming language like Python, and all of that. Um we have objects, we have class, okay, and we have what we call in Python we have mapping, we have map, and so on and so forth. So all of this, how we construct mapping are different, but in Solidity we are constructing. Solidity is very, very interesting, okay, because now we are creating an object here. In our storage, want to create a storage, and we say in this storage it must have a key value pair. That means we are creating an object to hold a large number of value in our storage. And but now we are saying the key is going to be of this type. So let me say the type of key we are going to be using is going to be an unsigned integer. I can decide to use byte as the key. I can decide to use string as the key. Okay, I can decide to use even enum, even this enum here, even this enum, I can decide to use it as a key. I can say, okay, the key is this, but I will get to there. You will see how that you see that this mapping has a lot of use cases, and it's really very, very interesting. You can see how you can work with different type of data. You can manipulate them to use it for desired results. So let me just use an unsigned integer here, and the value it will hold, the type of the value it will hold, will means that it will hold, let's say it will hold a string, okay, and I'll call it names. So this, I am constructing this. You can see this mapping now, okay. The concept of variable is applying here. I am using a keyword called mapping for Solidity, and I am constructing it. I am invoking it. When I'm invoking it, I'm passing the type of data inside it, okay, that it will take. Then I am say, okay, oh, this is the reference name, this is the variable name. So each time I want to access this object, this storage here, I have to reference it using this named variable. So that is what it means. So internally, this will create an object for us, but differently, not the usual object like this. No, a hash map object, a hash map object. Solidity will hash each of this key. We hash each of the value. We hash it. Okay, everything will be hashed. So that is the reason we cannot iterate through this object. We cannot iterate it. But there are libraries that helps you, to navigate your way by iterating over mapping. So they are really interesting. So, but we get to that later. So now we have actually defined names. So this name now, anytime we call this name, let's just create a function. For example, let's say I want to register some names in my system, in my contract. I say function, okay, register. Yeah, tell me your name, string, memory, okay, memory. Tell me your name, underscore name. Why I use underscore name here is this, because if I use the same name, I will be pointing to these names here. So there will be a collision, a kind of collision here. So I'm just distinguishing between this memory type of kind of name and the name I have in the storage. So I'm going to say this is public, anyone can access it. So what it does is this: I'm going to register the user calling this in my system, in my contract. Names, and I'm just going to say names. Okay, I'm calling this, I'm referencing the storage. Look here, Mr. Storage, I want to store something here. Okay, so I am invoking that storage. The storage is actually doing nothing if I don't invoke it. So I am invoking that storage. The storage, look here, I want to make use of you. Storage, you now answer me. Okay, now how do I store things in this storage? Because this is like an object. Okay, this is like an object. And remember, in Python, when you store, let me come here. Remember in Python, when you say, let's say for instance in JavaScript, you say constant, my object is equals to this. Okay, and you say the key value, let's say the key is name, and this, and you say the value is my name. Say the value is Bob. Okay, all right. So this is just the concept that is being represented in Solidity here. What you see here, this is exactly how it is going to store for you, but different in the way that if you are using this name here to save space and to be efficient, Solidity is hashing this key for you and hashing this value for you. So each time you want to retrieve it, it's going to perform the same, hashing the same process. Okay, all right. So that's just what it means. So now in JavaScript, for us to accept this my object here, to access this name, to get this value here, and this value is our last destination. So for us to get this value inside this object, we have to do what is called, we have to invoke my object. We have to invoke the reference. When you invoke the reference, we use a square bracket. Okay, that means we are passing in the index that Bob is residing. But here in this case, the index is in this type, and that is one beautiful part of objects in programming. Objects are really very interesting, and because they are very dynamic and they can do a lot of things. So I'm just going to invoke this by say, okay, look here, this is the key. Get the value residing in this key for me. Okay, what I've done here is I've invoked this my object, and I pass in the parameter for it. This parameter gets me the last destination that is in this position. So that is exactly what we are going to be doing here. So we are invoking the names, and we are saying, okay, look here, the type of data that I am expecting, you're expecting, I'll give it to you. Okay, let's say in the data residing in the first position, which is index 0. Okay, in the first position, um store it, change it to what? To this name, set it to this user, Okay, so by doing this, I have simply registered this user calling this function. I have simply registered him in my what? In my storage. But then, no, basically, I am not actually keeping track of this caller calling this function. So he can just pass in anything he likes here, and next time it comes, it can pass in the anything. So I'm not, it's just like for example for now. So we're not really taking any security measure for now. So but instead of doing something like this, I could just say let this the key be address. Let it be an address that is holding a name. Okay, so that means let this person calling this function, I'm just going to get the person, because there's a way we can get the current caller of any function of anyone interacting with our smart contract, and we can access them using the global data, sorry, global data type. I'll be global what is called it, a global object, sorry, a global object called message. Okay, message, and this object contains some members. Okay, so for us to access those members, we can use the dot operator. Okay, when you do the dot operator, you can access sender, you can access the sender, or you can access message.data. That means the data the caller of this contract is calling this function with. Okay, the data, it might probably be passing along the call with the call. So message.data, message.sender, or message.value. Message.value is like when you are sending ether, you are sending matic, all of that. Okay, all right. So instead of using this message dot here now, instead of using that unsigned integer, just go to use message dot sender. So this will be referencing the current person, the address of this person calling this contract, and here is his name. So when else is coming, I can always check if this person has the name in my has a record with me. So if it has a record, there's no need to set another record. So but in the next lesson we are going to look at that. So right now, lastly, let's quickly look at another user defined type called struct. Called struct. Okay, struct. Let's say I want to define my custom data. Okay, all right, my custom data. So in Solidity, like I told you, we have elementary types. Okay, elementary types like they are like unsigned integer, 256, and other data types. You can see this one enum is a user defined type because we created this data ourselves. Okay, and this data also, this struct, my custom data, we want to work with more data. Like for instance, now I want to here I only set the name of user in my system. This user could probably have I could probably want to use more data than just the name. Maybe I want to have access to his age. Let's say I want to have access to his age, unit 8, age. Okay, I want to have access to his name, string, his name. I want to have access to let's say um his surname, string, other names. Okay, okay, all right. So let's just leave it at that for now. Let's say I need this data and I want to be able to group my data in one place, and I'll be able to access them easily, and I'll work with them efficiently. So instead of defining I can, because if I use, let's say I don't, there's no way to use this custom data now, and I want many users in my system. So I could only define this like this. I could only say, look at um user one, string name string user one name. Sorry, my keyboard. User one underscore name. Okay, then I could say string user two underscore name, and so on and so forth. Okay, if I need 100 users in my system, I could be defining them like this. So this is really not good. Okay, it's really not good, and I don't think anybody programmed this way. Okay, but to be able to work more efficiently and do data very well in your contract, Solidity allows us to create a custom data, and this custom data, look at it here. I just create okay, let me just use profile instead, and it has to start with capital letter, uppercase. Okay, so here, instead of using the name alone, I could just map it to the profile. I could map user address to the profiles. Okay, so anytime the user comes, I input the address here. It's going to fetch the user profile for me. Even if they are 100, they are 200, they are 1 million, I could store everything inside this object. Even if they are more than that, 2 million, I could store everything inside this object. But my storage will keep expanding. That's the only implication there. Basically, the major implication. Okay, so right now, instead I get error here. You can see that I am passing in the wrong data type. Instead, I am setting a string here, this string underscore name, instead of setting it to profile type. So let me now fix this problem. I could just say profile constructors. Okay, so positionally, we are going to set the attribute, the property, sorry. So the first one is the age. Let me say I want to undo the age for the user. I don't want user to set his age. I know the age of the user, and I'll say, Mr. Man, your age is what? Is 50. Is 50. Okay. Then I say the second, your name. Okay, you can tell me your name. Now, passing the name positionally. Okay. All right. So then other names. What are other names? Okay. I know you give me your name now. Let me just generate other names for you. Let me just call you something else. Let me just call you good guy. Okay. All right. So right now you can see now the error is gone. So that's it for today, guys. If you don't understand this, I will advise that you just watch this video again, and so that you have grab more understanding of what we are doing. It's always good to have the basic and foundational knowledge of any programming language for you to be able to do more with it. And if you see hackers hacking smart contract and all of that, those hackers are really intelligent guys, because hackers understand how things work from the grounds up. So they understand each of, you know, they can manipulate those data. And for you to manipulate data, you need to understand what that data, how it is being created, how it works, the concept around it, and what how it can be what you can perform on it. When you understand the basic concept, you'll be able to have the creative ability of using that data. But if you do not understand, then you can only be one way. It's as in you can only be copying code and be using people's code. But a lot of time, working with other people's code is even more tedious and time consuming than when you have to write code yourself. I'm not saying you shouldn't use other people's code, but basically myself, I prefer writing code, especially Solidity, myself, my own code, than having to copy people's code and work with it. Even if I have to work with Open Zeppelin code, I don't just believe that everything is okay there. I still have to go through those contracts or code I need to use to ensure to understand how it works before I can be able to use it. So that's it for now. In our next lesson, we'll get to understand and I'll communicate with you on the Twitter. If you have not seen the previous video and the tweets I make, I will drop the link in the description so that you can access them. Thank you very much, guys, for watching. If you like this video, please share with your friends. Also give me some like and help other people to reach it. Thank you very much. See you next time.